angles, which you're like, Miss Quigley, the top of this thing says segments. You're right, that's a whole typo. Can you please cross out the word segments and put angles? We are measuring and constructing angles today. Measuring and constructing angles. Yes, so join us back with this. Now, angles, you're going to be familiar with a lot of things about angles because you've studied them before, but it was in middle school and it's been a minute. So I'm going to go over some things for you. An angle is a figure formed by two different rays that have the same endpoint. This is important. The unit of measurement for angles is degrees, which is the tiny little circle. Kind of looks like an exponent, but it's not the exponent 0. It is a degree marker. So here's a nice, cute little example of an angle. Do angles look familiar to you? Should a little bit. The vertex is the shared endpoint of an angle. You can kind of think of it as the elbow or the turning point of the angle. So my vertex for this angle is right there. It has a vertex. And there are 3 ways we can name an angle. There's going to be one that we're going to use most often, but if you ever read something online or in a textbook, there are multiple ways to name an angle, but you'll discover why we're going to use the method we use in class a lot. So in this angle that we see here, we can name the angle by its vertex. The vertex is the corner point or the turning point. What is the letter at the turning point? A. So we can call this angle A. Whoa, pause for a second. Do not make that an L. That is not an L. It's a tiny little angle symbol. Do not make it a less than symbol. It is an angle symbol. So it's flat and then a little bit angled. It means angle. We're going to use that symbol for forever. It is angle A because we can name it by its vertex. We can also choose to name it using a point on each ray and its vertex in a particular order. So for example, I could say C, A, B. So I would name it angle CAB. Or I could just reverse those letters, angle BAC. What do you notice is in the middle of both of these triples of letters? A. Why is A going to be in the middle? We're like turns, right? It's called its vertex. The vertex has to be in the middle. The third way we can name it, and this is not as popular unless it's printed out of a textbook, is by a number. So if you notice, there's a tricky little number sitting in the middle of the angle, which means we could also, since it's already named angle 1, we can just call it angle 1. We won't use that one nearly as often because it's pretty vague, and if it's not already numbered for you, you can't just add a number. The one we're going to use the most is option 2, where we pick 3 points. That's the one I'm going to use the most. That's the one you should use the most. Is that clear? Let's practice naming, because we know naming stuff was kind of difficult when we did points, lines, and planes, so let's make sure we can name angles. We're going to rename the angle below in 3 different ways. First, let's do it by its vertex. What is the what is the letter at the vertex? Q. So we can call this angle Q because that's the vertex. We can also use 3 letters. What's one of the 3-letter combinations I can use? PQR, fabulous. What's the other 3-letter combination? RQP. Can I name it angle QPR? No, why not? Q has to be in the middle. So yeah, if you wrote that down, say not that one, because you can't name it that way since Q was not in the middle. Very good. Can I name this one by a number? No, there's no number there. Numbers are going to come from like a textbook or something. If I give you it being numbered, you can use a number. If I don't number it for you, you have to use letters. Okay, cool. What if I give you like a complicated angle and I want you to name 3 different angles from the image on the right? Okay, 3 different angles. Here's what I see with my eyes. I see that there's this angle right here. How would I name the blue part? EFG or GFE. Yes, but I'm going to just write one of them down. I could also name this angle that's different. What would be the green one called? GFH, very good. And then how is there a third angle?
Because
HFE.
The big one. Yeah, we have this big angle that both of them combine to make, which we can name, just like you guys said, HFE. Yes. Oh, that is a great question. So just using angle F would be problematic. We're not really allowed to do it in this situation. Why is that problematic? Look at how many used F as their vertex. Is it clear which of these I'm talking about if I just say angle F?
No.
It's not really clear. So using just angle F would be problematic because it's not specific enough. We know what the word specific means, yeah? Detailed. There are 3 options of things that could use vertex F, so I have to be more specific than just saying F. Yes?
That's still cool.
Next topic today is about classifying angles. So now that we've named them, we need to classify them into 4 categories. Now these categories are going to look familiar to you because again, you would have done this in middle school probably, but you've had like a whole nap and a whole summer since then, so I get it. The first type of angle we have is called an acute angle. We would start at what's called standard position and go this direction. Why is that an acute angle? What do you know about its measurement? It's small. Specifically, it is less than 90 degrees. That's the less than symbol, not the angle symbol. So maybe we write those words down. Less than 90 degrees. Any angle that is less than 90 degrees is an acute angle. What do we know about right angles? It's equal to 90 degrees. Now remember, if we're talking about degrees, you got to put a little degree symbol or else it's wrong. Why do I know that this is a right angle? What has shown up on it? The little box thing. Any square, like corner, is a 90-degree angle. We are still measuring from here to here to make 90 degrees, but that box indicates that it's 90 degrees. Okay, cool. Does this sound familiar? Oh, obtuse. What do we know about obtuse angles? More than 90, less than 180. So we're just going to say that it's greater than 90 degrees. It is less than 180, but for ease of our notes, we're just going to say bigger than 90 degrees. And then the kind of angle that everybody forgets about is called a straight angle. You're like, that's not an angle, Miss Quigley, that's a straight line. You're right, it's also a straight angle, because if I put a vertex in the center and I drew my angle going up and around, it's a straight angle. But since it's a straight line or a straight angle, it is exactly equal to 180 degrees. So any flat line has 180 degrees. That's how we would classify angles. Now, if I didn't tell you what they were and I asked you to measure it, you're going to measure them using a protractor. Now, I have physical protractors we will practice with later, but on your paper we have a fake one. What you will do to use a protractor is you will place the vertex or the midpoint of the protractor on the vertex of the angle. So there's going to be a little bitty hole in your protractor. You put that on the vertex. Then you line up one of the sides with the 0 line of the protractor and read the degrees where the other line crosses the number scale. Meaning, like on these 2 examples, if I wanted to measure GHK, grab a colored highlighter for me. GHK. So if I go G to H to K, that's the angle I'm measuring. Notice that my vertex is in the center of the protractor, here, and that one of my edges is lined up on 0, here. Do we see that? All we have to do is measure this angle. So if I count from 0 all the way to that angle, how much is that degree? Ooh, it's past 90, all the way from red to red. What's the number that it's pointing at on that protractor? 125, but if you answer that it's wrong, what do you put at the end? Degrees. Now let's classify it. 125 degrees. Is that acute, right, obtuse, or straight? Obtuse because it's bigger than 90 degrees. What about JHL? So grab a different color highlighter, please. You might have to share with your friends. And we're going to highlight from J to H to L. Now we notice again, the vertex is here in the center, and this time our 0 is starting on this side. But if we count from 0 up to that angle measurement, how much is it? 90 degrees. What kind of angle is it if it's 90 degrees? Right. Ooh, 90 degrees exactly is a right angle. Acute is when it's less than 90. Our last one is kind of tricky because, again, reading a protractor, you just like look at the numbers. If we're going from L, so here's L, to H to K. Oh, boy. I didn't really set my protractor up right, but that's okay. I can still read this. If L, the ray HL, is pointing at 90, I'm going to write that down. And if HK is pointing at 125, how much was this angle from here to here? 35 degrees. 125 minus 90 is 35 degrees. What kind of angle is that? Acute. Very good. It's an acute angle. If you're like, what? How'd you get 35? Guys, just count. So 10, 20, 30, 35. You can just count along your protractor. We will practice at the end of class reading an actual physical protractor that I will give you to practice with. But obviously you don't have these at home, so that's going to be our classwork, and your homework will be practicing other parts of today's lesson. But this will be classwork today. I think you will. You'll notice that I already have one filled out because I'm actually going to skip that example doing live. But if you go look at my notes on the YouTube video, or on my notes that I will upload onto Google Classroom, you can see that method for number 8. Okay, so again, I'm not gonna go over that example, but it's there for you if you go back and look for yourself. We're gonna do the first two together on this page. Now what we're doing on this page is dealing with what's called the angle addition postulate. If you remember, we learned about the segment addition postulate before. It's the same thing, but apply it to angles. What it says is, if you have a point in the center of an angle and it creates two angles, RSP and PST, then all we have to do to figure out what the big angle is add them together. So it says RSP plus TSP is equal to RST. Little angle plus little angle equals big angle. Don't overthink it. It's just like a segment. You're confused. Okay. If I labeled this RSP, little angle, and PST, so I have the blue and I have the green. If I put them together, blue and green make what? RST? Yes, the purple. And it's going to be the measurements. So just like we did with the segments where the two small pieces add together to make the big one, it's the same thing. Okay? So if we apply that to a problem here, angle 1 plus angle 2 equals total angle, and we want to find JKL. Here's what I know. I know that JKM is worth how many? And I know MKL is worth how many? So I'm going to be able to use those numbers and figure out the whole thing. Yes, some of you are probably doing it in your head already, but I want you to write some geometry down for me. The geometry we're going to write is the following. Angle JKL plus angle MKL should be equal to angle JKL. I just used the wrong letters for one of them. This one. I'm so sorry. JKM plus MKL equals JKL. Blue plus green equals purple. Angle 1 plus angle 2 equals total angle. Does that part check out? That's the geometry for today. We fill in with the numbers or values we get from the image, which is 31 degrees plus 85 degrees equal to what? What is 31 plus 85? Oh, we have calculators next to us. 116. All right, great. So guess what? Angle JKL is equal to 116 degrees. Boom. That's the angle addition postulate. We add them together to make the big angle. There's the geometry. Are we okay with the geometry?
Yeah.
Okay. Can I put some algebra into it?
No.
Gonna do it anyways. Thank you for your honesty. All right. For the next one, we want to find CAD and BAD.
Math.
Yeah, I know. But say the letters because it's, it's a whole thing. Okay, well, here's the things I know. Based on the angle addition postulate, I know that angle CAD plus angle BAD should be equal to what angle? Oh, it is a right angle, but what are the letters we use to describe it? CAB or BAC, yes. Okay. So if we plug in what we know, just like we did a second ago, the first problem we had a whole bunch of numbers, so it was super simple. In this problem, we're going to have expressions. Now I'm going to let you do something that's not really great algebra, air quotes, great algebra. You do not have to put the degrees until the very end of the problem, especially when we're solving for x's because it gets confusing. When it's plain numbers with degrees, I need the degree symbol. But when you know you're going to solve some stuff, you can just ignore. But you got ahead of me because if I get to this point, I need a measurement for the purple angle, and there was no numbers there. But what number do you know that it is?
90.
Why do we know that it's 90?
Oh, because
Because the little box. What does the little box tell us? That is 90 degrees, called a what kind of angle? Very good. All right. Now here's the deal. I know that this is the part where I'm getting a lot of people stuck on these problems. We're not stuck on geometry. We get geometry. Little angle plus little angle equals big angle. We're getting stuck on algebra. I talked to a bunch of algebra teachers on Monday, like when we had our day off, right? And they were like, oh, well, don't forget about the box method. And I was like, oh my gosh, I forgot about the box method. Some of you guys had me for your Algebra 1 teacher a few years ago, and I taught this method and I completely forgot about it. So I'm going to go over the box method in case you're familiar with it or you like it. And anytime we solve an equation, you can use it. The box method is as follows. Draw a line down the center of your equal sign and put two giant boxes on either side. Each of these boxes have a top row and a bottom row. I got it. What this does is it visually organizes solving equations, because that's where we get lost. We get lost in what goes where and what does it do. The way that you use these boxes is you look at your equation that's left. How many terms have an x in them? 2. So on the left side, you need 2 top boxes. How many terms how many terms up there in the colorful part have 3 terms? Sorry, wow, I just gave you the answer. How many terms up there do not have an x on them? 3. 1, 2, 3, yeah? Okay, all we have to do now is drag and drop them where they go. Anything with x's goes on the x sides. Anything that's a plain number goes on the plain number side. So we drop the x right here. Pow, it's there. But when I drop the 15 to its box, it has crossed the center line. What do?
it becomes a negative.
It changes the sign. So it was positive, now it's negative. I drop the 5x where it goes, no change. But when I drop the 57, what happens? Cross the line, change the sign. So that positive 57 becomes negative 57. Do I need to change anything about 90? No. Okay, those of you who know the box method, what do you do with all of the numbers in the top of your boxes? We add them together. Very good. So 1x plus 5x is 6x. If you're like, where'd the 1 come from? It's invisible right there. You might have to do this one in your calculator. What is negative 15 plus negative 57 plus 90? Always add, even if we're adding negative numbers for the box method. 18, very good. Now there's one last step to finish the box method. Who remembers what it is? We do divide. What are we dividing by? 6, just 6, just the number in front of x. But what we do to one side, we must do to the other, so that means x is equal to 3. Those of you who learned the box method last year or like what I've done just now, You are more than welcome to always use the box method when I say solve for x. I might not show it. I'm going to try to go back and forth between the two methods because they're really the same thing. One is just more visual than the other. But if you like this, please use this. Totally allowed. Sorry, I forgot until just now. Okay, cool. Are we finished with the problem though? No, because what was the actual question?
We need to find that.
We need to find the angle measurements. We need to find the blue angle and the green angle. So I know that the blue angle CAD, was equal to x plus 15. But what can I put in place of x right now?
1. Wait, 6?
3, the number we got for x. What is 3 plus 15? 18. So that means angle CAD is equal to 18 degrees. That's where I have to have the degree number, or else it's wrong. And that's not me being picky. 18 as the answer to an angle is 18 radians, which we will not learn about to the second semester. We want to talk about in degrees. You have to put degrees or it's straight up different. Not me being picky. That's actually correct and not correct. Bless you. Now, if we wanted to find angle BAD, there's 2 ways we can do this. I will show you both. Number 1, we could plug it in. So this would be 5x plus 57, but instead of x, what am I putting there? 3. I'm not just going to put it next to it, though. I'm going to put it in parentheses. We'd bleep, bleep, bleep. Type it in our calculator. You would get 72. Or, remember that these two angles have to add up to 90 degrees. What is 90 minus 18? 72. If they have to add up to 90 and one of them is 18, that means the other one is 72. Whichever method makes the most sense for you, you use. If you're like, I'm just going to plug and chug all day, Miss Quigley, great. Plug and chug all day. Now again, this third example is already pre-filled for me on my notes. I forgot to write it on yours before I printed it. I'm so sorry. If you want to write this down, I'm not going to leave it up there for very long. You can go access my notes on Google Classroom and copy it down if you're interested. But it's another example exactly like number 7. Good? Can I keep going? New topic. Actually, it's not new. It's an application from something else we learned. We're going to talk about congruent angles and angle bisectors. When it was a segment bisector, it cut it in perfectly 2 pieces. So an angle bisector is going to do the same exact thing. Congruent angles are 2 angles that have the same measure. We're going to indicate they have the same measure by these tick marks. I want you to highlight the tick marks right here. Those little tick marks mean that those angles measure the same degrees, as if that arc or the ray cuts it directly in half. Something you're going to see a lot that I need us to start recognizing is that when they use multiple types of arcs, like here, do you see how the first angle has 2 little arcs and a second angle has 1 arc? That's indicating that they're 2 different sizes, size 1, size 2. So those are not congruent, but the tick marks tell us they're congruent. Now an angle bisector, same like a segment bisector, is a ray that divides an angle into 2 congruent pieces. Congruent meaning same angle, like it was same length for segment bisectors. So this is the word you're going to look for, bisects. When it bisects, you're thinking equal parts. Bisects equal parts. Bi means 2, sect means intersection, intersecting into 2 parts. All right, let's apply this to some problems. The first thing we want to do is find DEG and DEF. Okay, if I look for DEG, that angle is right here. How much is the measurement of angle DEG? 92. Great, look, I'm already halfway done. The next part of this question says GEF. Based on those tick marks in the image, how much is this angle?
92.
Also 92. Very good. Look, I didn't have to do that much work because I recognize that it's a segment bisector. A bonus question for you, though. If I asked you, what is the measurement of angle DEF, how would you answer that? 92 plus 92, because we know if we add those two things together, we get the bigger angle. That's 184 degrees. Notice again, I've put degrees after every time I've answered. If you say 184, no degree mark, you're talking about radians, which is not what you mean to talk about yet. We need to talk about degrees. They're doing experiments in the class downstairs. That's what you're hearing. If anybody's in IPC, that will be you later today. Let's do number 10. Okay, we have a new image. It says that QR bisects, oh, spidey senses should be tingling. Bisects means that it cuts it perfectly in half. It bisects angle PQS. We want to find PQR and PQS. Those are the things we want to find here. Okay, the information we're given is a little bit different. I'm given information about angle PQR and RQS. But since the word bisects is used, what do we know about this length, or this angle measurement, and this angle measurement? If it says bisects, what does that mean? It divides it into two equal pieces, which means those two angles should be what? The same, equal. That's the concept that we are going to use to solve this question. So the geometry we write down is the following. Angle PQR is exactly equal to angle RQS. That's what we know from the word bisects, that they're equal. In fact, for your notes, I want you to put a little arrow. Bisects means that the two colors are equal. I've written things for a long time. I've written a lot of math in my life. If we fill in what we know, the measurement we know for angle PQR is 4x minus 10, and the measurement we know for RQS is negative 3x plus 130. Again, when there's x's involved, you can lose the degree symbol as long as I get it back at the end. I'm going to allow you to do that. Now, again, if we want to solve for x, I'm going to review that box method because I think it's helpful to see it. But if you don't like it, you can use inverse operations. I mean, we're doing the same thing, just in a different order. But for these boxes, how many top boxes for the x side? 2. How many top boxes for the non-x side? 2. All right, let's drag and drop. 4x goes here. Do I change anything? No. Negative 10 goes over here. So what does it change to? Positive. Negative 3x goes all the way over here. What is positive? You beat me to it. And then 130, do I have to change it? No. Now one more review. What do we do with the stuff in the top? We add them. 4 plus 3 is 7. 10 plus 130 is 140. We divide by what number? Divide by 7, divide by 7. This is exactly what you would do if you were solving with inverse operations. We'd end up at the same answer. So totally allowed, mathematician's choice on that one. Cool, amazing. I'm done with the algebra. Let's go back to a geometry question. What am I actually asking for you to find? The angle. Angle which one? PQR, which is the blue. So angle PQR should be equal to, and I'm going to have to scoot over. I apologize. It might not be enough space. 4x minus 10. But instead of x, what am I putting there now? 20. 4 times 20 is 80. 80 minus 10 is 70 degrees. So I know this is 70 degrees. How can I figure out what PQS is worth in an easy way? It's, oh, thank you for saying that. What's the same thing? Which colors? Which colors at least are the same angle? Blue and green, yeah. The blue and green are the same, right? So we found out this was 70, which means what is the other one? 70. So remember, I want the whole purple one. So the answer here is not 70. What is the answer? 140. We had to double that answer because it bisects it. So if we want the big angle, we just have to double it, or 70 plus 70. So you got to make sure you're answering the right question at the end because it didn't ask for the green part, it asked for purple, which is so tricky. That's it. Here's what we're going to practice in class because you can't take protractors home with you. I'm about to pass this paper out to you, but I need to show you how to do this before I let you go. Herlin, I'm going to volunteer you to pass out protractors in a second, so hang on. What we're going to do in this paper is we're going to measure these angles. I will take my protractor when you get it, and you will put the little center mark on your vertex. Okay? This is way too big for my tiny little protractor, but you get it. Then you're going to take one of the flat lines and move it onto one of your flat lines. And then read the numbers that go towards the angle you want. This really is not going to make sense until you play with the protractor. But the vertex goes on the little dot. The flat line that looks like a ruler goes on one of your flat lines. And then you read the protractor like we did on the first part of the notes. Yes? This is going to be due before you leave, so I need you to measure all of these angles. There's only 12 of them I need you to measure. And then you can turn it in, and then we can work on your quiz again. Yeah. Yeah. But when you're done and you turn it in, if you want your quiz back to keep working on it, I will give it back to you so you can have more time. Okay? If you're done with your quiz and done with this, you can work on some homework.